Okay, so next question is 2006. Basically applying a maths question here, so we'll just start off. Okay, so lift starts off from rests. For the first part of the descent, it travels with a uniform acceleration f. It then travels with a uniform retardation of 3f and comes to rest. The total distance is travelled d. Find the time taken is t. Okay, draw a speed time diagram for the motion. Okay, so let's just imagine the lift here. Okay, so we have two lines. As usual, it's going to be velocity versus time. And what we're going to have next is we're going to have, now what you got to look at when drawing your diagram is comparing the acceleration to the deceleration. The deceleration is 3 times stronger than the acceleration. So this means that you're going to get to the same velocity, you're going to spend 3 times longer getting to your final velocity than you are decelerating. So it takes longer to accelerate to the velocity than it does to decelerate. So your graph will look something like this, where you go all the way up to v. Okay, so we'll cap off v, the velocity, around cap off the velocity around here. Okay, now see this distance from here to here? That's going to be 3 times longer than the distance it takes to decelerate down. So we're going to decelerate our distance down, and it's around here, just doing it by eye. Okay, and then we're going to know that this here is going to be v. Okay, so we're going to have 2 times t1 and t2. Okay, now the way we can do this is we use tan alpha and tan beta. Tan alpha and tan beta give us the acceleration and deceleration. Okay, so acceleration, which is equal to 3f, that equals tan alpha. Tan alpha is opposite over adjacent, which is v over t1. Basically 3f equals v over t1. Okay, so v over t1. Okay, now what we can do the same thing for the deceleration. The deceleration is going to be sorry, the acceleration was f, excuse me. Okay, the acceleration was f, not 3f. The deceleration is 3f. Okay, so the deceleration is 3f, which is equal to tan beta. Tan beta is opposite over adjacent, which is going to be v over t2. Okay, tan beta, which is v over t2. And what we're going to get is 3f, excuse me, 3f equals v over t2. So when we rearrange both formulas, what we can see is that t1 equals v over f, and t2 equals v over 3f. Okay, so what we can say is that t2 is 3 times smaller than t1. Okay, so if we want to get a ratio of t1, if we want to get t1 divided by t2, all we have to do is do this. We can say v over f divided by v over 3f. Okay, and then we can say t1 multiplied by t2 is the same thing as v over f multiplied by, bring this up, turn it upside down, and when you turn it upside down, you're going to get 3f over v. Okay, then you're going to get t1 over t2 equals 3. t1 equals 3t2. Okay, t1 equals 3t2. Now, what we can also say about t2 is that the entire time is t. Okay, so I'm just going to rub this out now because I don't need these workings anymore. Okay, so I'm just going to rub these out. keep using my diagram. Okay. So all we have to do here, if you were to look at the total time, okay, so what we could do here is look at the total time. The total time here is t, cap big T, okay? So it wants us to find the distance d in terms of f and t. It doesn't want t1 and t2. No t1 or t2. So let's start off right away and get rid of t2 and put it in terms of t and t1. So t2, just from here to here, is the same thing as t minus t1. Okay? T minus t1 equals t2, okay? So let's try and find the total distance traveled now, okay? So total distance, that's equal to the area of the big triangle plus the area of the small triangle, okay? So we're going to add the two of these together. And what we can do here is basically, let's find out what it is, okay? So this is VT1. This one here was VT2. So it's going to be a half VT1 plus a half VT2. Okay. And what I want to change T2 into, okay, so half VT1 plus a half VT2. Okay. Now, because we know the ratio earlier was 1 to 3, so the ratio, if T1 equals 3T2, the ratio is 1 is to 3. Okay. So we know that T1 is a quarter of the total time. So T1, excuse me. We know that T1 equals 3T2, okay? So what we know is that if we're to portion this into the total time, okay, T1 is worth, T2. So let's portion this out, okay? So T1 is 3 times bigger than T2. Okay, to T1. And what we know is that T1 is going to be 3/4 of the time, and T2 is only going to be 1/4 of the time. Okay, so that makes perfect sense with that. Okay, so now we're going to find the total distance, and we're going to get a half v times 3/4 t. 3/4 of the time goes to T1, and then we're going to get a half v times 1/4 t, because basically 1/4 of the time belongs to T2. Okay, T1 and T2, and then what we're going to get together, going to put them in together, and what we can get is the total distance, okay, is going to be, let's add these together, okay, so we're going to get 3/8 VT plus 1/8 VT equals a half VT. Okay, so we got the total distance in terms of v and t. Total distance is in terms of v and t. We want d in terms of f and t only, okay? So we don't want v there, okay? V, we don't really want v there, okay? So we have to figure a way to get rid of v, okay? So what we learned earlier was that f equals v over t1. So f equals v over t1, okay? So then what we learned is that f equals v over 3/4 of t. So f therefore is equal to v. F equals v multiplied by, bring this up, turn it upside down, so it's going to be 4 over 3t. So f equals 4v over 3t. Okay, so f equals 4v over 3t. So what we can do is we can just put this in here, so equals a half So we don't want the v, so we need to get rid of the v there, okay? So the whole point was to get rid of the v. So get v on its own, and when you get v on its own, v being the target, what we need to do is v equals 3 ft divided by 4. Okay, 3 ft divided by 4, so equals a half 3 ft divided by 4 multiplied by t, and then the total distance is going to be 3 over 8 ft squared. Okay, and that's going to be your answer for that question there, right? Very tricky part, to be honest. Very tricky part A. Okay, next one is going to be a part B, right? And this part also reasonably tricky. Okay, two trains P and Q, each of length 79.5, moving in opposite directions along parallel lines. Meet at O when their speeds are 15 and 10 meters per second respectively. The acceleration if the acceleration of P is 0.3 and the acceleration of Q is 0.2. It takes a train t seconds to pass each other. Find the distance travelled by each train in t seconds, hence or otherwise calculate the value of t. How long does it take for 2/5 of the length of train Q to pass the point 0? Okay, so what you got to remember about this question is basically you're looking at a very long line here, okay, so a big line here, okay, and the next thing we have is we're going to have, if I can get it here, two trains, okay, so we have trains. Ideally I don't want this square, I'd like a rectangle. Let's see what else I can get here. I'll just draw a rectangle, probably a bit easier. Okay, so I'm going to draw a rectangle in green to represent one train. Okay, now both trains are of equal length. Okay, so I'm just going to draw the point O in here as well. So it's always handy if you have time just to do a rough drawing, okay, of what's going on. And then I have train Q here. Train Q, one of them in red and the other one in green. Okay, so I'll just do it here. Roughly the same length. Okay, and here we go. Okay, so let's see what we can make of this. Okay, so the first part is basically, this is the point 0, the point O. Okay, two trains P and Q, train P, train Q. Okay, let's write down information about Q. Okay, so Q, well, let's say Q is going at 10. So Q is the second set of information, so Q is 10. So U equals 10. And then its acceleration is 0.2. V is going, U is going to be at 15. Acceleration is going to be at 0.3. Okay, and then it takes t seconds for the trains to pass each other. Okay, so we have to find out what is the length there. Okay, so it takes t seconds, so they both travel for t seconds, so we need to u-vast both systems. Okay, so find the distance traveled by each train in t seconds. Okay, so what we need to do is we probably need to u-vast both systems, so we're going to u-vast them, v-a-s-t for P and u-v-a-s-t for Q. P, so let's find out. Okay, so U equals 15, V we don't know, A is 0.3, S equals T, or sorry, T equals time, S we don't know really at this point in time. For U, we know that that's going to be 10, acceleration is going to be 0.2, t equals t. Now, we only really know two variables for sure, and the rest of the variables we don't know. So we're going to need some extra item of information from the question, okay? But the first part of this question just wants us to find the speeds of the trains in terms of t. So we can do the first part of the question quite easy, without any additional thinking, okay? So the first part of the question, find the total distance travelled in t seconds. That's not too bad, okay? So the distance travelled by each train in t seconds, that's not so bad, okay? So it's just going to use s equals ut plus a half at squared, and we're just going to put them in here, okay? So we should be able to find these quite easily. So s ends up to be 15t plus a half 0.3 times t squared. So we're going to get 15t plus 0.15 t squared. Handy enough. That's s of p. Okay, s of q. Same thing. We're going to get 10t plus a half 0.1 times t squared. And then we're going to get s of q. Ends up to be 10t plus 0.1 t squared. Okay. So let's go back up the top here, okay? And see, might need to put in a bit of information, okay? So when doing this question, you got to figure out something else, just another piece of information that may really help the general cause of doing the question, okay? So we're going to go for size 11 here, maybe even size 9, okay? And let's try and type this out now, okay? So in order for both trains, in order for both trains to be clear, their full lengths must be clear of each other. Okay, so the full lengths must be clear of each other. Now, however, because they cover distance at different rates, even when P has covered 79.5 meters, because P is the faster train, covered for Q still hasn't covered 79.5 meters. Okay? Okay, so basically the distance of both, the distance P covers and the distance Q covers has to be equal to the length of both trains, okay? Because both trains, okay, from here all the way to here, that is basically the length of two trains, okay? So both of them have to cover a distance equal to this to clear each other, okay? So to clear each other, they both have to do this. Okay, so if I was to just say, move this here, okay, so I always move this way, okay? They gotta clear each other, they gotta clear by each other. So they might not be completely passed out, because P will cover more distance. Okay, so what P will do is it'll cover more distance. So when P moves, okay, just gotta deselect Q here. So when P moves, they might not actually, because Q is moving slower, P will actually be out here when it happens, okay? So that's what we gotta be aware of, okay? So S of Q plus S of P equals twice the distance of the train. So S of P plus S of Q equals 2 times the distance of the train, so equals 2 multiplied with 79.5, and that's going to get us 2 times 79.5 is 159, okay? So let's write down the big formula of this. So we're going to get 15t plus 0.15t squared equals, plus s of q, t squared plus s of q, which is going to be plus 10t plus 0.1t squared. That's all going to be equal to 159. It's a quadratic equation, okay? So what's going to happen is it's a quadratic equation, so we're just going to add them both together, and what happens is we're going to get 0.25t squared, 0.25t squared plus 25t, 0.25t squared plus 25t minus 159 equals 0. Okay, let's divide everything. Let's multiply this by 4, because we want to get rid of that 0.25t squared. You go straight into the minus b formula if you want, but I'm going to do this plus 100t plus 100t minus 636 equals 0. Factorize this, use the minus b formula, whichever one you want. Okay, so when you do this, what's going to happen is you're going to be left with t minus 6, or t plus 100 plus 106 equals 0. Remember, t cannot be equal to minus 106 seconds, because time can't be negative, so t equals 6 seconds. Okay. Now we're on the third part, alright? So the third part is find how long does it take for 2/5 of the length of train Q to pass point O. So this question has nothing to do with P, has everything to do with just the distance Q, okay? So that's all we want. So it's not as difficult as the second question. In fact, it has nothing really to do with the second question, okay? So we have our line here, and what we're going to do next is we're going to draw train Q. Train Q being the red one. Okay, so it starts off, let's say, at the point where it's just about to join point O. Okay, so it's just here at the moment. The train is here. It's at point O. Okay, and then it's going to go by it, and it's going to cover 2/5 of its length. Alright, so let's say 2/5 of its length would be around here. Okay, so what we're going to do is we're just going to select it. Okay. Move it through, and about 2/5 of its length around here. Okay, so what's going to happen is, for this question here, for part 3, it's got to cover how long does it take for 2/5 of the length of train Q to pass the point O. Nothing to do with train P. So all what we got to do here is just say, okay, we're just going to say S of Q. The distance Q covers is 2/5 of basically 79.5. Okay, and S of Q, as discussed before, is 10t plus 0.1t squared equals 2 times that is going 2/5 of that is going to be 31.8. Okay, then we're going to bring it all over one side. Let's make a quadratic equation out of this. 0.1t squared plus 10t minus 31.8 equals 0. Multiply everything by 10. You get 1t squared plus 100t minus 318 equals 0. Okay. I just go straight into the minus b formula. Does it give any information? Doesn't really go into the minus b formula. So t equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay. And what's going to happen here is a equals 1, b equals 100, c equals minus 318. Just go through that, and you'll find out that t basically equals 3.085 seconds. Okay, had to go through the minus b formula, I'm afraid. Okay, next question, which is 2000. I think we're basically on 2000 and I think we're on 2005 now. Okay, so we're on 2005. Okay, so 2005A. Okay, so 2005A. Car A and car B in the same. Car A and car B travel in the same direction along a horizontal straight road. Each car is traveling at a uniform speed of 20 meters per second. Car A is a distance of d meters in front of car B. Okay. At a certain instance, car A starts to brake with a constant retardation of 6 meters per second. 0.5 seconds later, car B starts to brake with a constant retardation of 3 meters per second squared. Find the distance car A, the distance traveled by car A before it comes to rest, and B, the minimum value for D for car B not to collide with car A. Okay, so there's lots of stuff going on in this question. Okay, so let's start off by you've asked in both systems, car A and car B. So we go for car A. So let's see what we can do when we you've asked car A. Okay, so car A, each car is traveling uniform speed 20. That's grand. Car A is distance d meters in front of car B. That's grand. At a certain instance, car A starts to brake. Okay, so it's traveling 20 meters per second. He starts to brake, and all of a sudden he gets minus 6. It happens there, right? And in front of car B, car A travels. Starts to brake, constant retardation. Starts to brake, constant retardation. Comes to rest is the next piece of information we need. We know that v equals 0. Okay, so for the first part, we know that we want to find the distance traveled. Go straight forward. You could use v equals, you could do two formulas, v equals u plus at, followed by s equals ut plus a half at squared. But we might as well just go for v squared equals u squared plus 2as and just go straight for the answer. Okay, so we're going to get v squared is u squared plus 2as. 0 squared equals 20 squared plus 2as, which is going to be minus 20. Minus 12 times s minus 2 times, plus 2 multiplied by minus 6 multiplied by s. Bring the 20 squared over, you're going to get minus 400. Minus 400 equals minus 12s. The distance covered is going to be 400 divided by 12. And this is going to get you 100 over 3 meters. Okay, so 100 over 3 meters. Okay, this traveled A before it comes to rest. Okay, now the minimum distance for D for car B not to collide with car A. Now the minimum value of D, okay, means the distance has to be away to not to collide with car A. Okay, so what we need to figure out is that car A is ahead of car B. Okay, car B is over here, car A is here. And what happens is car A starts to slow down. Okay, and what's going to happen is B is also going to start braking. Okay, so B travels, first of all, car A and car B. A immediately starts to brake. Okay, so A starts to brake and it starts to go slower. Okay, and in this time, B doesn't react. Okay, so B doesn't react at all. So B starts to brake 0.5 seconds later. So B actually travels quite fast in this extra second. Okay, so B travels quite fast there. Okay, so what's going to happen is the two of them are going to travel. So A is still traveling, and so is B. Okay, so their initial distance was D apart. Okay, now both of them are going to end up at the same point. For the minimum distance, okay, both A and B are going to end up at the same point at the end. Okay, so they're going to travel the same distance from the start. Okay, so if we let S be the distance A travels. Okay, so let S be the distance A travels. Okay, which we know is going to be 100 over 3 before it comes to rest. Okay, and D is going to have to D is going to have to catch that up. Okay, so let's take this first instance. Okay, now we're car B, so we're going to go for car B. Car B actually travels that extra bit of so it travels U equals 20, and it travelled that for 0.5 of a second. Okay, so this is before it brakes. Okay, so what happens is it travels 10 meters per 10 meters. Okay, it travels 10 meters before it applies the brakes. Okay, so the brakes are applied here. It travels those 10 extra meters. Okay, so U is going to be UT plus half AT squared, but it's just going to travel UT 20 times 0.5 is those 10 extra meters. Okay, so next thing we're going to do is now car B, once it actually has its brakes applied, so car B is going to have its brakes applied. U is going to be 20, V is going to be 0, okay, because it has to go all the way to brake. We know that car B can actually decelerate a lot faster than car A, or decided to decelerate a lot faster than car A at -3. S ends up to be, we don't know what S is and we don't know what T is. Okay, so for car B we can use V squared equals U squared plus 2AS. Okay, and what we can get is 0 equals 400 minus 2AS, which is minus 6S. So distance is 400 divided by 6. So S equals 400 divided by 6, which is 200 divided by 3 meters. Okay, so when car B decided to jam on the brakes, okay, so when car B decided to jam on the brakes, what happened was it first traveled 10 meters, okay, at full velocity. So it traveled 10 meters at full velocity. Then it traveled a further 200 over 3 before it completely came to rest. Okay, so when we add them together, okay, so we add 200 divided by 3, which is 66.6 meters. Okay, and what I also needed was those 10 extra meters before it stopped, so plus 10. Okay, and you get 230 over 3. So 10 plus 200 over 3 equals 230 over 3 meters. So that's how much distance it took B to stop. Alright, and what we know is that A, if you get B here, okay, we know that A covered 100 over 3 and B needs 230 over 3. Okay, so what we can get is the 230 over 3 meters, okay, that B took to decelerate. So basically, if you look at it, A moved further on, A moved to here, and this was 103 meters. Okay, B was initially a distance D behind. Okay, so basically the D plus 103, D plus 100 over 3 has to equal the full area, the full length it took B to decelerate. Okay, so when this happens, this is the formula we're going to be left with, equals D over 100 over 3. Therefore D is going to be equal to 130 over 3, which is 43.3 meters. Okay, now, okay, so for the next question, a mass of kg falls freely from rest, 8 kg falls freely from rest. After 5 seconds the mass penetrates sand, and the sand offers a constant resistance R and brings the mass to rest in 0.1 of a second. So if you imagine the ball is falling down, or the mass, it takes 5 seconds to go from top to bottom. Once it hits the sand, which we'll put in yellow here, okay, so it hits the sand, which is here. what happens is it travels a further 0.01 seconds, which is quite a small amount of time, like literally a fraction of it. And what we had to find is find the constant resistance of the sand and the distance the mass penetrates into the sand. So the first thing we got to realize is that we got to find out how hard does it hit the sand, what pace does it hit the sand at. Okay, so the first thing we can do is need to UVAST the system, so UVAST, and acceleration is working for us, so it's going to be 9.8. U is going to be falls from rest, it's going to be 0. We don't know A, but we know T is, we don't know S, but we know T equals 5 seconds. So what we can use is speed after 5 seconds equals phi equals U plus AT. Phi equals 0 plus 9.8 times 5. The velocity it's going to hit the sand at is 49 meters per second. It'll hit the sand at 49 meters per second, okay? Now, once it's in the sand, it's starting off velocity. We're going to do UVAST again. This is when it's in the sand, okay? So this is free falling. This part here is free falling, and the part underneath is when it's in the sand. U is going to be equal to 49. Phi is going to be equal to 0. A is equal to point. We don't know the acceleration just yet. Excuse me. We don't know the acceleration just yet. And S is going to be equal to we don't know that yet either, but we know that T equals 0.01. Okay, so all we gotta do is put these values into V equals U plus AT. So we're going to get 49 minus 49 equals 0.01 A. Therefore A equals minus 4,900 meters per second squared. Okay. Okay, so the next part of the question is when the mass hits the sand. Okay, so when the mass hits the sand, what's going to happen is there's going to be several forces acting, right? So the forces acting is, first of all, the resistance is acting against the motion of the particle, so the resistance acts upwards, alright? The next thing you need to know is that the weight of the particle is still pushing it down, so the mass by gravity still pushing it downwards, and what happens is the net force. What actually happens is the net force or motion, okay? So the formula we're going to get here is we're going to get the weight acting downwards minus the resistance, and the resistance is acting upwards, equals the net force, okay? And the net force equals net force, okay? So what happens is the weight is mass by gravity, the resistance is R, and the net force is mass by acceleration, m by a. Now what happens is we lug our numbers in. 8 kilograms multiplied by 9.8 minus R equals 8 times. Now the actual deceleration, minus 4,900 meters per second. Multiply them out, isolate R on its own, and the result is the resistance is 39,278.4 newtons. Okay.